Hi class, we're going to continue with our 12.4 notes here. This is our part 2. We're going to be talking about inverse functions, inverse equations. So exponential functions and log functions are inverses of each other. Graphically, what happens if we have an an exponential function and a log function with the same base is they end up being a reflection of one another over the line y equals x. So you can see the line y equals x here, this diagonally dashed line. And if you think about like a butterfly effect, that's like the butterfly body. And then a reflection from there means that the other two pieces should be symmetric to each other like butterfly wings. I like to think of it. So as long as you've got that reflection, you have two inverse functions. Algebraically, what it means, if one function is an inverse of another, it means you can use one of them to undo the other function. For example, if I need to solve for an exponent, I can use a log function to undo the exponential. So we're going to look at two examples here where we algebraically find the inverse equation of logs and exponentials. The first step, so here's your steps here, is going to be to switch the x and the y in the equation. So here, I don't see a y, but we all know hopefully at this point that y is the same as f of x. So I can rewrite this here just in a different form so we can see that y variable. And then my first step, so step 1, is to switch x and y. So I'm going to rewrite it. X equals log base 2 of y minus 1. So I've switched x and y in my equation. Step 2 is to isolate the variable. Now this can be a little tricky because if we look at where the y is, it feels like we want to add 1 to get it away from the y, but we can't because it's part of the log. So I have to undo the log first before I can move that 1 away from it. And the only way to undo the log is to change to exponential form. So remember I said algebraically, if they're inverses, we can use them to undo each other. So to undo the log, we need to use exponential form. So if I rewrite this in exponential form, I get 2, a base of 2, with an exponent of x. So remember, this ties into our last part 1 lesson. So this one here is the base. And then this one here, the log equals the exponent. All right, so if you are unaware of that, you might want to go back and watch my 12.4 part 1 lesson. All right, so 2 to the x power equals y minus 1. Now, because there's no log attached to the y, just y minus 1, I can now add 1 to each side and rewrite this as y equals 2 to the x plus 1. And then step 3, there's just one more tiny important step to do. If my function was written initially as f of x, I want to make sure to write my inverse equation in function notation. F inverse of x. There's almost like an exponent. It's not really, it's just notation, but it looks like a little exponent of -1. And then I'll just rewrite what I have, 2 to the x plus 1. Okay, let's do one more example where we go the other direction. So we're going to start with an exponential function. We're going to find the inverse. So again, the first step, so I can rewrite this as y equals 3 to the x plus 5 up there in the exponent. My first step for finding the inverse is switch x and y. So now x equals 3 to the y plus 5. Now I need to isolate the x. So step 2, I want to get not isolate the x. We want to isolate the y. I want to get the y by itself, but I can't really do that without using logs. I have to somehow undo the exponential part since y is an exponent. And the only way to do that is to change to log form. Sorry, my pen is lagging here. Okay, so if I'm going to change this to log form, so again, we practiced converting between exponential form and log form in the last part 1 of the video lessons here. So we'll have log base 3, And then I like to leave a little space. I know my exponent goes over here. So y plus 5 is going to go over here where the exponent, the log, is the exponent. The log equals the exponent. And then my argument of my log is going to end up being x. Now I just have to get y by itself. So at this point, I can subtract 5 from both sides of my equation. I get the log base 3 of x minus 5 equals, oops, my pen stuck there, equals y. And then, like I said before, it's important to use our inverse function notation. Originally, this was g of x, so I'm going to write g inverse of x equals log base 3 of x minus 5. And there, whoops, that doesn't look like a 5. Sorry about that. And that is how to find inverse equations between exponents and logs.